For example 2, this one takes a little bit more work. You have two sides and an included angle. So here are your two sides in B and C, and then your included angle is A. You need to find your remaining angles and side. So we need to find our side A. We also need to find out what angle B is and angle C. So we find out what angle B and C are and side A, then we'll be finished with this problem. So let's use our law of cosines to find A. We'll say A squared equals B squared plus C squared minus 2AB cosine of A. So A squared is equal to your B, which is 9 squared, plus 12 squared minus 2 times 9 times 12 times the cosine of 25 degrees. Now, with your big honking calculators, you can plug these in all at the same time. You just have to be careful how you do it. So using your graphing calculator, let's just plug this in exactly how we have it written. So we're going to say 9 squared to the second plus 12 squared minus 2 times 9 times 12 times the cosine of 25 degrees. Make sure you are still in degrees, so let's check my mode here. Woo! Good thing I checked, because I would not have gotten the correct answer. So make sure you are in degrees. And we can go back to our problem, and we can say enter. And we get A squared is equal to 29.24. Say 29.24. So if you take the square root of both sides, A is going to end up being approximately 5.4 meters. So there is your A. Now, in order to find out what our angles are for B and C, we could have we got to think about other possible measures that could be for B. Well, since A is acute, an acute angle, that means if you have 180 degrees minus 25 degrees, you have a total of 155 degrees to split up between angle B and angle C. So that can be any combination. That could be 155. That could, so you have an obtuse and an acute angle. That could be two acute angles. Maybe you had 70 and 85, or other possibilities. So any of let me rephrase that. So you actually have two possible answers for angle B, and we're going to find angle B first. So let's look at just using our law of sines. And if we're trying to find B, we can say the sine of B over side B, which would be 9, is equal to the sine of A, which is 25 degrees, over side A, which is 5.4. So if we solve this equation using cross multiplying, and actually I'm just going to multiply both sides by 9. So let me back that up here. So if I multiply both sides by 9, that just gets rid of your 9 in the denominator over here. So you get the sine of B is equal to, and when you plug this value in, you're going to end up getting a 9 times the sine of 25, and that's going to be divided by 5.4, which is a 0.7044. Now, if you think about this in terms of radians, okay, sine is positive, so this is a positive 0.7044. There are actually two values on your circle where your sine is positive in two quadrants. You have one in quadrant 1. So you'd have an angle up here in quadrant 1. And then you're also going to have an angle up here in quadrant 2. So we need to find out what those two angles are, and then we'll verify if we should find C, which of those two we should use. So if we find our sine of B, and we plug this into our calculator, we need to find the arc sine. So B is equal to the arc sine of 0.7044. So our first angle, our first theta, that would give us a value of 44.8 degrees. So that's our first angle. So that means this angle on your triangle from your 0 up, that's a 44.8. Well, this is also a reference angle that you would have to use on the other side of your triangle. This would be 44.8 degrees here. So your second theta would be whatever 180 minus 44.8 degrees is, which is 135.2 degrees. So we have two different options here. So say we have theta 1, so we'll call it side B, or angle B sub 1. That could be 44 degrees, 44.8 degrees. And then we're going to have an angle B, this will be our second one, which could be 135.2 degrees. Now what this does, this doesn't change your angle A, but it does change your angle C's. Because for your angle C, you have to add together your 25 degrees and your 44.8, subtract that from 180, so that would give you a 110.2 degrees. And for the second possible theta, you have a 25 degrees plus a 135.2, which is a 160.2, which would give you a 19.8 degrees. Now, here's where you have to use a little bit of your thinking. In this case, case 1, your side angle, or your angle, is 110 degrees. Oops, wrong color. Okay, it'd be 110 degrees. 0.2. And then this is 5.4 over here. And then this would be a 44.8. Now this would make a little bit of sense because your bigger angle must be across from your larger side in your triangle. So if this is your larger side, that's 112, 9, 5.4. If you made this a, I can't even see here, angle C, if you made that 19.8, then that would mean that your angle B would be 135.2 degrees. Well, here your bigger angle is across from not necessarily your larger side. So if that is the case, and that's not possible, then your second case that you solve for, this is not true. So your actual answer for your B and your C would be these two values. So we're going to plug those into our answer up here. So angle B would have to be 44.8 and C would be 110.2. So you get your solution of your side A, your angle B, and your side C. Now let me recap real quick why we had to do two different B's. We did two different B's and we got down to the point here where we got sine of B as a 0.7044, which means on a triangle, or on your circle, there are two values where your sine is positive, quadrant 1, quadrant 2, and we found a reference angle of 44.8. So that would be from 0 in your first quadrant, 44.8. In your second quadrant, you would take 180 minus 44.8, which gave you a 135.2. So those are two different possible values for B where your sine is equal to a 0.7044. We subtracted those values, or added those values to 25 and subtracted from 180 to find out your other possible C values. And we found out that what was written in blue did not work because what was written in blue, your angle B is 135.2 and your C is 19.8. 19.8 is the smallest angle that can't be across from your largest side. Not possible. 135 is your largest angle that can't be across from your middle angle. Remember, your larger sides always across from your largest angle. So a lot of information in that problem, but you just have to double check when you get two answers And that only occurs when you get an acute angle like 25. So if you get an acute angle such as this, I don't want to use that color, or that color. If you get that acute angle right there, then that is where you have to use two sides and double check. So hopefully you didn't get too confused. If you did, make sure you ask some questions.